Right. So in the previous session, we went through some of the very basics of object-oriented programming versus procedure-oriented programming. So in the two essence of the lecture, we try to understand how object-oriented programming differs from the conventional programming approaches that we have learned. So today again, we will learn about two very basic concepts of object-oriented programming. The first one is called an object, and the second one is called a class. So object, of course, you can understand. Object-oriented programming is the programming that is oriented or that is based on object itself. Right? It's a very simple thing to understand. But we will today go through what exactly a object represents and what exactly a class represents in this programming approach. Fine. So what are objects in object-oriented programming? So the first and foremost identity of an object is that it is the basic component of a program. So in object-oriented programming, whenever we start out by writing a program, the most basic component of any program is the object. So an object is the basic component of a program in object-oriented programming. Right. Again, when can we create an object? We can create an object at runtime. So runtime is when we have actually written the program, we have compiled it successfully and we are executing it, right? So that is when we can create an object. Fine. So the code for creating an object is essentially kept within a main function, right? But the objects are created at runtime. When the program is being executed, only then I can create the objects. So they are called runtime entities. They are called runtime entities. Now, each of these things you have to remember so that you can properly define or explain about an object, right? So since it is a runtime entity, obviously it is created at runtime and it is valid only during the program execution. So as long as the program is being executed, the object is valid for that whole duration. Beyond that, the memory allocated to the object is no longer valid. It is erased automatically. Okay. So when we are actually creating an object, some memory space is allocated for that object during its execution. That memory space is used for working with the object. Once we have finished execution, that object memory is completely removed, right? It is not valid after the execution is over. Okay. Next, ideally, an object represents a real world entity. It could represent a person, a laptop, a table, a pen, etc. We have been through this in the previous class. We will again go through these examples today again. Okay. But that does not mean that we do not have the right to use objects as per our will. We can also use objects to represent user-defined data, right? So there can be an object for simple interest. There can be an object for compound interest, right? There can be objects for defining different time zones and so on. So the basic thing to take away from this slide is that an object is created at runtime. It is the most basic component of any program, and it is valid only through program execution. That is, the memory allocated to an object only exists all through the program execution time. Right. Next, we find that any problem in object-oriented programming is analyzed in terms of objects. So whatever problem somebody hands us, we will try to analyze that problem initially in terms of the objects that that problem contains. So every problem has to contain some real world reference, right? So it will have some objects. It will have reference to some objects. So first of all, we need to analyze what objects there
Sir,
are.
can you repeat once? My buffered.
Yes, sure. This slide?
Yes, sir. Yes, sir.
Okay, okay. No issue.
Yes, sir, for
Uh,
this.
no issue, no issue. I am repeating. So as I said, uh, any real world problem that somebody gives us, okay, what we do is we first analyze that problem and we think how we can represent, how we can represent that whole problem in terms of the different objects that that problem contains or that problem represents. Any real world problem is always analyzed in terms of the objects that it corresponds to. Fine. And the second thing that we need to do is we need to determine how these objects can intercommunicate. So the first thing is, what are the objects that belong to a programming problem that we have to devise? And the second thing is how these objects can intercommunicate. Now, all of these things will obviously be more clear, more and more clear when we are actually working with objects. And we will come to that in the next few lectures. But for now, we just have to understand this, that whenever we are working with object-oriented programming, the whole purpose is to break down any real-world problem into the inherent objects. Fine. So the objects are carefully chosen to closely resemble the real-world entities. So I have to ensure that the objects are close enough so that I can model the real world. And obviously, the objects are allocated memory. So they have an associated memory address. So if you have worked with C programming, you already know that any variable has an associated memory address, right? It is allocated a random space in memory. Similarly, same thing happens for objects. So when we are creating an object during program execution, so again, that object is allocated some memory space. Fine. So we have to understand what the memory space for an object actually means, and we are coming to that. So each object contains some data values in variables, and these are called instance variables. Why instance variables? Why this name instance? Because instance actually represents an object. So basically an object is a particular implementation of a class, right? So we use the term instance in place of an object. An object is nothing but an instance of a class. It is a specific implementation of a class. It's a specific form of a class. Okay. So the variables that any object contains, they are called the instance variables. Now, both of these concepts will be clearer in a few minutes. Right. So every object contains some data in variables, and it contains some functions that work with the object's data. Right. So object will contain some data values. Every real world object, let's say my laptop or my smartphone, it has some properties which I have to represent using some data values. And how can I represent data values? By using variables. Fine. So that is the very simple reference that we can draw. Next thing is, my laptop has some functions, and these functions are more or less dependent on those data values, on the properties. So there is the behavior that my laptop has, right? So how to represent that in programming? I can represent that in programming by using functions. Now objects can interact without knowing the details of each other's data or functions. So if my laptop and my mobile phone try to interact, they do not need to know, my laptop does not need to know what is the weight of my mobile phone or what is the color of my mobile phone. Though those things are properties of my mobile. My laptop can interact with my mobile phone without knowing the details of each other's data or functions. Fine. So these are again a few properties that the objects have. But let us now take a very up till now, I hope there was no connection issue. Everybody could hear what I said, right?
Yes, sir.
Okay.
Yes,
Thank
sir.
you. Thank you. So let's take another example now. So in front of you, I hope you can see you have a real world object, right? Which is a mobile phone. So towards the right side, you have a real world object. And towards the left hand side, you can see that how we model that object in object oriented programming. So it is written, the object name is Poco F1, which is the mobile phone's name. The data that this object contains, right? This is represented in the form of instance variables, and each instance variable has a specific value. So RAM equal to a specific value, battery capacity has a specific value, weight has a specific value, internal storage has a specific value, right? So the instance variables for a particular object have specific values. This is something that we have to understand. For an object, for a particular object, such as the Poco F1 smartphone, every instance variable has a specific value, right? This is how we model that object. And there are some functions that this smartphone can perform, such as it has super cooling technology, high-end gaming is possible, it has 4G support, video calling is enabled. These are all the functions of this smartphone. And there are many more. This is not limited to this. So whenever you are modeling a real world problem, it need not be a smartphone, it need not be a laptop, it can be anything, right? It can be anything. But for that real world object, you have to determine what are the data values and what are the functions which I can use, which I can bundle together in order to properly model this real world object in object oriented programming. So that is the whole essence of how objects are used in object oriented programming. I hope up till this part we are clear. So if we are clear, just type in a yes in the chat box. So we can, so let's draw some conclusions about objects now. We have been going through a lot of things about objects. So there has to be some point of conclusion, right? So let us come to those conclusions one by one. So as we saw here, an object is nothing but a bundled form of data and functions in the object-oriented programming model. That is what we have written as a conclusion. Object equal to bundled data and methods. Methods here represents functions. So the data describes the specific state of an object. Now this is very important. The data values, instance variables, they describe the specific state of that particular object, right? So in my case, when I have this smartphone, the specific state of that object can be described as per the RAM it has, the internal storage it has, its battery capacity, its weight, its color, and all those things. Fine. So the data values can be used to represent the state that my particular object has. Fine. The second thing is the functions or methods, and they describe the behavior of the object. They describe, or they help me describe, how the object behaves at particular situations, in particular circumstances, how my object can behave, what, how will it work, right? That I can describe using the function or methods. So for any object, it has two things, two crucial components belong to every object. Otherwise, it is not, it has to have a state, right? It has to have a state and it has to have a behavior, right? So as I said, the data describes the specific state that my object has, right? So if I have this real world object, right? So it represents, it is represented in object oriented programming in this form, and that we have understood. Fine. But this data, which is the RAM, the battery capacity, the weight, the internal storage, each of these data values help me to represent my real world object. So they represent what is the state of my object, what is its color, what is its RAM, what is its battery capacity, right? So these are the particular states or properties of my object. Fine. And the second thing that we have is the functions or methods which describe the specific behavior of the object, how my object behaves in particular circumstances. How does my object behave, right? So for that we have certain functions. We can write certain functions. It can have super cooling, it can have 4G support, it can have video calling, and so on and so forth. Please note that these data and functions are not restricted only to these values. It can have many more values, right? Okay, so hoping that this part is clear. So we can say that objects have independent existence. Now this is also something that we have to convince ourselves. Every object has independent existence. So if I have a Poco F1 smartphone that can exist independently from an iPhone 11, it is not at all dependent on the iPhone 11. Similarly, if somebody has a Realme C3, that is not dependent on my Poco F1 or the iPhone 11. So every object has an independent existence. That is something very commonplace, right? And the characteristics of the objects are, the other two characteristics are, it has a state or attribute. which is denoted by the variables used by the objects, and it has a particular behavior which is denoted by the functions performed by the object. So what changed? Nothing. Nothing changed. Here we saw what does the object contain. It contains data and it contains functions. So this is the view of a programmer. Whenever we are writing a program, this is the view of a programmer, right? That object contains data and it contains functions. Very good. But what is the view of somebody who is trying to relate how that object in programming is representing a real world model? He or she can find that object has the following characteristics. An object has independent existence. An object has a particular state or attribute which is denoted by the variables, and an object has a particular behavior which is denoted by the functions that the object is performing. Let's move on. So next we come to the concept of a class, and it is written that a class is a user defined type, or UDT. So at this point, I would like to ask you all, have you ever worked with a user defined type? Can you name a user defined type? Please type it in the chat box. If you have ever worked with a user defined data type, please type its name in the chat box. Right. So as some Ayush has said, okay, PU is saying float. Okay, fine. So I get how you're thinking. So have you ever worked with something called a structure? Yes. Yes, Sumanto is saying yes. Right. Okay, thank you. So you have worked with something called a structure. Right. So let us get something very clear at this point of time. Okay. This you are supposed to know from your previous classes. Anyhow, we have some inbuilt data types in C programming. So what are those inbuilt data types? We have some primitive data types and we have some derived data types. Just try to understand. We have some primitive data types and we have some derived data types. So what are the primitive types? The primitive types are char, float, int, double, long, and so on. These are the primitive types. I hope you have heard of this term. They are called the primitive data types. Next, we have something called the derived data types. And what is a derived data type? Array is the prime example of a derived data type. So what is the property of an array? An array contains a collection of contiguously placed items in memory, right? And the items have to be of the same type. So essentially, what is an array? An array can be visualized as a collection of character type elements, or a collection of integer type elements, or a collection of float type elements, right? So in essence, an array is actually nothing but a derived type which is based on the primary data types or the primitive data types. And again, what is a primitive data type? It is a int, byte, float, sorry, not byte, int, float, long, char, etc. I hope I am clear. Okay, so again, a primitive type is something that we have worked with. Then we work with a derived type, which is an array in C programming. Fine. And then we have something called the structure. Now, when you have worked with a structure, you know that a structure has a basic advantage over an array, and that is why we use a structure. Can somebody tell me what is the structure advantage of a structure over an array? Just type it in the chat box. You are giving me wonderful answers, so I expect you to answer this as well. What is the advantage of a structure over an array? Just type what you think. You may be right, you may be wrong. Again, it does not matter. Okay. So Ayush says it uses dynamic memory allocation. Very good. Anything else? Yes, Ayush. Okay. It allocates memory during runtime. Anything else? Any other advantages or primary differences which you can find between an array and a structure? Okay, so it appears that nobody else. Okay, fine. So a very primary point of difference, Ayush is absolutely correct, by the way. Okay, so a structure is allocated memory, and structure can have exactly. So this is the actual answer that I was looking for, Ayush. Very good. Thank you for the answer. Structure can have different data types in the same structure. Array cannot. So essentially what he's trying to say is that a structure can have heterogeneous elements. It can have elements of different data types, elements of different primitive types. Whereas an array is nothing but a derived data type, right? So a derived data type is based on only a single type of primitive data. A derived data type is only based on a single type of primitive data, whose prime example is an array. It is based on either a character type data or float type data or integer type data and so on. But a structure has a primary point of advantage. What is that advantage? A structure is a user defined type. It is not a derived data type as such. It is a user defined type. So let us just move back to our presentation and we'll try to understand what and how. So what do we mean by a user defined type? So example of a user defined type that we have used, it is called a structure. So in C programming, we have worked with structures. It is a heterogeneous collection of variables that can be referenced by a single name. So just as an array is referenced by a single name, but it is a collection of homogeneous variables. It is a collection of variables of the same type. Much the same way, an array is a heterogeneous collection of variables. So the variables can be of different types of data. So in order to work with a structure, we first define a structure type to use it as a template. So we have to define a template or a blueprint for a structure type. And then we create structure type variables, right? So first we define what this user defined data type will contain as data. First we have to define that, and then we can create n number of variables of this type. Just as I can have a n number of variables of integer type, just as I can have n number of variables of float type, similarly first I have to define what my required structure type will contain, and then I can create n number of variables of that structure type. So this is something that you should be able to recollect from your C programming lectures, and I hope this part has worked as a quick recap. Fine. So structure is nothing but a user defined type. So as an end user, as a programmer, I can actually define what sort of a data a structure will contain, and then I will use that definition. I will use this data type that I have defined to create any number of variables that I want, any number of variables of that particular structure type. So moving on, it follows that the user defined types are special data types that the user can define. That is, these are not predefined. So I can get to define what I want to have, right? Ayush can get to define what he wants to have. So UDTs are defined using the existing primitive or basic data types like int, float, char, etc. This is again something that we already know. User defined data type like a structure right now. The structure that we have worked with, that is based on the primitive data types or the basic data types, right? User can create variables or instances of user defined types. So when I worked with structures, I could create a structure type variable. I could create n number of structure type variables. Fine. So this is all about what is a user defined type with the help of a user defined type that we have already used in C programming, which we call structures. So the last line is crucial. Class is also a UDT. The class that we use in object-oriented programming, that is also nothing but a user-defined type. Okay. So the set of objects with similar data and functions. The set of objects with similar data and functions can be visualized as a user-defined type called a class. So again, when I am saying a set of objects with user-defined types, with similar data and functions can be visualized as a user defined type called a class. By this statement, I mean that a class can be used to generate a set of objects which will have similar type of data and functions, right? Vice versa. So if I have a set of objects with similar data and functions, I can visualize them as belonging to a particular class. On the contrary, I can also say that if I have a class, then I can use that class as a template or as a blueprint, just like I use a structure. Just as I use a structure, I can use a class as a template or a blueprint to create a set of objects which will have similar data and similar functions. Fine. So we can say that objects work as the variables of the type class. So just as I could have a struct student and I could create variables of struct student as struct student s1, struct student s2, and so on. Similarly, once I define the user defined type called class with a particular name, I can create variables or instances or implementations of that class, which are actually called the objects of that particular class. Right? So I hope the whole transition from the understanding of user defined types using structures up to the understanding of a class as a user defined type is clear. Okay, right. So classes and objects, how it works. Now this is a very preliminary understanding for a layman, right? In layman's terms. This is not actually a very in-depth approach, but this is just an overview. So first we have to define a class. Just like first we define a structure, here first we have to define a class. It does not occupy any memory at this point. So when we have defined a class, it is not occupying any memory. We may create any number of objects of that class. Right? We can create n number of objects of that class. Each object is associated with the data and functions of their respective class type and occupy memory. So each object of the class has associated data and associated functions, which I get from the class definition. And each of these objects occupy some amount of memory. Just keep in mind that a class does not occupy any memory. It is nothing but a blueprint. It is nothing but a outline, a layout. Just as, let's say I had a program in C and there I had defined a structure, but I had not created any structure type variable. Would it have taken up any amount of memory? Just give me a yes or no in the chat box. What do you think? Let's say I have a structure that I have defined in a C program, but I have not created any structure type variable. So is any memory being occupied? Okay, Ayush is saying no. Aniket is saying yes. Shantanu is saying no. Aniket, why yes? If I have defined a structure but not created any structure type variable, why would it take up memory? It will not take up memory because there is no, there is no requirement for keeping any value because the user has not created a variable at all. He has only defined a layout. That's all he has done, right? So I think the general understanding that you people have is correct, that if I have a structure which is defined, but I do not have structure type variables, then there will be no memory occupied. There will be no memory utilized. Similarly, in the case of a class, if I have a class definition, but I do not have objects of that class, then no memory is occupied. If I define a class, that is all. The memory is utilized, the memory is used, it is allocated only when I define objects of that class type. Fine. Right. Now, if we, go back to this presentation, we will find that we have some deductions. So we can deduce that classes are essentially user-defined data types. Very good. Classes behave just like built-in data types. How? Because we can create variables of a class. How? Syntax to create an object of a class. The syntax to create an object of a class is the same as the syntax to create an integer or a float variable. So just like we create an integer variable by writing int a semicolon, we can create an object of a class by writing the class name followed by the object name. And this we will learn in the days to come. but this is a simple deduction. So just like there is a minimum difference in terms of creating variables of the structure type and of the integer type, similarly there is no difference in creating variables of the class type and of the integer type. So this is a simple deduction that can follow, right? So before coming to the definition of a class, I have another question for you people, and I want you to think about it. Now, from the lecture up till now, it has been clear to you that I have a class and I know what a class is. I also know what is a structure. So can you tell me what is the primary point of difference between a structure and a class? See, I am giving you some primary similarities. A class and a structure, they are both user defined types. A class and a structure, they both contain data of different types. A class and a structure both can be defined and they do not occupy any memory until and unless an object of the class or a variable of the class are created. That is all fine. These are the primary points of similarity. Just give me any point of difference that you have been able to deduce between an object and a class. Okay, Ayush is saying, sir, the class is like our batch containing all CSE students. And objects are all of us learning the subjects. Very good. That is fine. Uh, okay, okay. Thank you. Thank you. So Ayush, you are right about the class and object, but what is it different from a structure? So Ayush, could you unmute yourself?
Yes, sir.
Yeah, Ayush, what do you think is the primary point of difference between a structure and a class? Anything that comes to your mind. You can be wrong, you can be right. No problem. Do not worry about it.
So structure contains various type of data types, and in a class, in an object, we can contain different type of structures which are similar.
Uh, See, that is fine. What I am trying to just think about it. What you learned just now is that a class represents objects, right? So a class is nothing but a collection of objects of the same type. Okay, this is clear to you. Now, what does an object contain?
Object contains various attributes of the about the objects
Yeah,
and various
so
functions.
exactly. So what you're trying to say is object contains data and object contains functions,
Yes, sir.
right? So again, let us come to another conclusion that a class represents these objects. So essentially a class gives me the blueprint of what data and what functions an object will contain, right Ayush?
Yes, sir.
Good. And does a structure do the same, or does a structure only represent data?
So the structure only represents data because the variables we are taking in a structure are only
Right,
of different data types, like in
right,
char.
right, right. So the primary point of difference between a structure and a class is that a class helps us bundle the data and associated functions together, whereas in a structure we cannot actually define any function. We
We can
can
only
have,
represent the data.
yeah, we can have associated data only. So this is something that you have to understand. Okay, so this part I think is pretty much the same. So a class is defined formally as a user defined blueprint or prototype or template which represents the set of objects with similar properties and behavior. So very simple again. Let us break this out into a few parts. So the first part is it's a user defined something. So first keyword is user defined. The next thing is what is it? It is a blueprint or a prototype or a template. Very good. And the third point is it represents the set of objects with similar properties and behavior. So just three key phrases and my definition is complete. A user defined blueprint or prototype or template that represents the set of objects with similar properties and behavior. Well and good. Now a class specifies the data members and the member functions of its objects. So the point where we started today's lecture was how objects contain specific instance variables and corresponding functions. Now, who actually allocates or who actually decides or defines what data and what functions an object can contain? Who does that? A class does that, right? So a class actually, predetermines what data members and what member functions its objects can contain. Fine. So that is the main role of a class. So if somebody asks you to give a definition for a class, I expect you to write both of these together. The first one is obviously a formal definition. Following that, you just need to mention this, that the class specifies the data members and member functions of its objects, right? And obviously the data members correspond to the variables or the state of the object, and the member functions correspond to the behavior of that particular object, right? So more or less, using our text, we can have this summation that if I have a class called smartphone, I can create objects of this class by writing smartphone space object name, which is Poco F1, or smartphone space object name, which is 1 plus 8, and this can go on. So here Poco F1 and 1 plus 8, these are objects of the class smartphone. This is again a very simple example. Let's say if I had a user defined type, if I had a primitive type integer, I could create variables of type int by writing simply int space a, int space b. Same way, since class is a user defined type, and the name of the type is given as smartphone here, I can simply write smartphone space Poco F1. So Poco F1 here is the nothing but the name of the variable, or what we call for a class is object, and smartphone itself is the class name or the name of the user defined type, right? So this is just for your simple understanding. Fine. I hope you do not have any issues with this part either. So now we realize that objects are the specific instances or implementations of a class, right? So from this example where we had a class called smartphone and Poco F1 and 1 plus 8, they were the specific instances or example or implementation of the class of smartphones. So Poco F1 is a particular instance or implementation of the class. 1 plus 8 is another particular implementation of a class. Now this concept I am repeating time and again because this is the most crucial concept on which object-oriented programming is based, right? So a class will define a general layout for what its corresponding objects can have as property and how its corresponding objects will have as behavior, right? That a class will define, and each particular object is a specific instance of a general class. Fine. So next two slides, the last two slides that we have, they are more based on graphics, right? So I can have a class which name is smartphone and which has some particular state and particular behavior. Now using this class, I can generate n number of objects of this class. So the first object is the Poco F1 called the object called Poco F1, and it has some particular state and behavior. And see, its color has been given as green. So it has its own unique, its own distinct state and distinct behavior, right? So in order to represent that, for the general layout of the class, the state and behavior have been kept in a gray background, right? Now, each of these particular implementations, each of these objects, see, we have three objects right now. Each of these objects has its own distinct state and behavior. So for the Poco F1, it is colored in green. For the 1 plus 8, it is colored in red. For the Realme X, it is colored in blue, and so on and so forth. So what we are trying to determine, what we are trying to denote is that every object will have its own particular specific state and specific behavior which is distinct from any other object. In order to represent that, we have used different color notations. Now if again this is nothing new for understanding, this is just a visual representation. Now again, using the previous example we had seen for the modeling of a real world object, let us now try to understand how we do it in a proper manner. So first I have the real world object towards the extreme left. In the middle, I have something called the class. So based on many such real world objects in my program, I will model a class with the name smartphones, and I will ensure that all of these smartphones have some particular sets of data which are nothing but variables, and some particular functions which are nothing but how the smartphones behave. So this is a class that is modeled in object oriented programming. The class name is smartphones, and it has some particular data and some particular functions. Please note that at this point of time, these data variables do not have any particular value. They do not have any particular value which correspond to a particular object. No, because this is just the definition of the layout. This is just defining what actually the class will represent, what values it will represent, what behavior it will represent. That's all. So this is the class of smartphones. Once I have modeled this class, I can use this class model to actually generate n number of specific objects. So one of those objects we have already studied, whose name is Poco F1. And for this particular object, each of these data will have particular values. You see, the RAM has a particular value, 8 GB. There's a particular battery capacity. There's a particular weight. There's a particular internal storage. So in the case of this object, all these data values, they become the instance variables. So in this case, the RAM, battery capacity, weight, internal storage, all of these are called the instance variables. Why? Because these are the variables which denote the value of this particular object. The particular object being Poco F1. Similarly, I can have a particular object called 1 plus 8, and I could have different data, battery capacity, weight, and internal storage. And that would be unique to that particular object itself. But for the general class, each of these data values has no particular value. Each of these data variables has no particular value, no particular state is defined. We are only giving a general idea that what are the properties that this object, that any object of this class will have. That's all. The particular implementations are called the objects. So that is why, whichever way you think, the class is nothing but a user defined data type, which helps me mention, which helps me model how a real world entity can be represented in programming. Right? So I hope this last slide makes the whole, summary clear enough for you. So with that, we will come to the end of today's presentation.